Imagine a world where materials could heal themselves. A world where cracks in your phone screen vanish overnight. A world where potholes repair themselves before your very eyes. This is not science fiction, but the dawn of a new era in material science. We are on the cusp of a revolution, driven by the development of self-healing materials. These materials possess the remarkable ability to repair damage, extending their lifespan and ushering in a future of unprecedented durability and sustainability. From tiny microcapsules to intricate molecular structures, the science behind self-healing is both fascinating and full of potential. These materials are poised to transform industries, from construction and automotive to healthcare and electronics. Join us on a journey into the world of self-healing materials, where the impossible becomes possible, and the future of material science unfolds before our eyes. The secret to self-healing lies in the ingenious ways scientists have designed these materials, pushing the boundaries of what we thought was possible. Imagine tiny capsules, invisible to the naked eye, embedded within the material itself, waiting patiently to perform their magic. These microcapsules contain a healing agent, a special chemical substance ready to spring into action the moment damage occurs. When a crack or scratch occurs, it ruptures these microcapsules, releasing the healing agent into the damaged area. This agent then flows into the damaged area, where it reacts with other components of the material, initiating the repair process. Like a magic potion, it binds the broken parts back together, restoring the material to its original state. There are other fascinating mechanisms at play too, each more intriguing than the last. Some self-healing materials are designed with special molecular structures that mimic the natural healing processes found in living organisms, like the way our skin heals after a cut. These materials can actually regenerate themselves at the molecular level, making them incredibly durable and long-lasting. The beauty of self-healing lies in its simplicity and elegance, seamlessly integrating advanced science with practical applications. By mimicking nature's ingenuity, we are creating a new generation of materials that are not only stronger and more resilient, but also more sustainable and environmentally friendly, paving the way for a future where materials can heal themselves, just like living organisms. The potential applications of self-healing materials are as vast as our imagination, spanning multiple industries and transforming the way we approach everyday challenges. Imagine a world where bridges repair their own cracks, preventing catastrophic failures and significantly reducing maintenance costs and downtime. This is the promise of self-healing concrete, already being used in construction projects around the world. These materials can extend the lifespan of infrastructure, making our cities safer and more resilient. In the automotive industry, imagine car bodies that can heal minor dents and scratches, maintaining their pristine appearance for years to come. This innovation could revolutionize vehicle maintenance and ownership. Self-healing coatings are making this a reality, extending the lifespan of vehicles and reducing the need for costly repairs. These advancements not only save money but also contribute to environmental sustainability by reducing waste. The world of electronics is also ripe for disruption, with self-healing materials offering new possibilities for durability and longevity. Imagine smartphones with screens that repair themselves from everyday wear and tear, eliminating the frustration of cracked screens and costly repairs. Self-healing polymers are paving the way for such devices, creating a future where cracked screens are a thing of the past. This technology could lead to more durable and reliable consumer electronics. And in healthcare, imagine implants and prosthetics that can self-repair, reducing the need for invasive surgeries and improving patient outcomes. This could greatly enhance the quality of life for many patients. Self-healing biomaterials are making this a reality, ushering in a new era of regenerative medicine. These innovations hold the promise of transforming medical treatments and patient care. The economic benefits of self-healing materials are as compelling as their technological marvels. By extending the lifespan of products and infrastructure, these materials have the potential to save billions of dollars in repair and replacement costs. Imagine a world where potholes are a distant memory, where bridges and roads last for generations, requiring minimal maintenance. Self-healing materials can make this a reality, reducing the financial burden on governments and taxpayers alike. For businesses, the adoption of self-healing materials can lead to significant cost savings in manufacturing, maintenance, and repair. This translates into increased profitability and a competitive edge in the marketplace. The economic case for self-healing materials is clear. They represent a smart investment in a more sustainable and prosperous future. Section 5. A greener future, the environmental impact. The environmental implications of self-healing materials are profound. By extending the lifespan of products, these materials have the potential to significantly reduce waste and minimize our ecological footprint. Imagine a world where landfills are smaller, where the need for raw materials is diminished, and where the environmental impact of manufacturing is minimized. This is the promise of a future where self-healing materials are ubiquitous. The production of traditional materials often requires significant energy consumption and generates harmful emissions. Self-healing materials, on the other hand, offer a more sustainable alternative, reducing our reliance on resource-intensive processes. By embracing self-healing materials, we are not only investing in a more durable future, but also in a greener and more sustainable planet for generations to come. Section 6. Frontiers of innovation, exploring new possibilities. The field of self-healing materials is brimming with exciting research and development, constantly pushing the boundaries of what is possible. Researchers are tirelessly working to create materials that can autonomously repair damage, making them more durable and sustainable. Scientists are exploring new materials, new healing mechanisms, and new applications for this groundbreaking technology. From polymers to metals, the scope of self-healing materials is vast and varied, each with unique properties and potential uses. One promising area of research is the development of self-healing polymers that can repair themselves multiple times, further extending their lifespan and enhancing their sustainability. These polymers could revolutionize industries by reducing waste and maintenance costs. Imagine a material that can heal itself indefinitely, like the mythical creature that rises from its own ashes. This concept, once the stuff of science fiction, is now becoming a reality thanks to cutting-edge research. Another exciting area is the development of self-healing materials that can adapt to their environment, changing their properties in response to external stimuli. These materials could be used in a variety of applications, from aerospace to consumer electronics. Imagine a material that can become stronger under pressure or more flexible in cold temperatures. Such adaptive materials could lead to innovations in fields where materials are subjected to extreme conditions. The future of self-healing materials is limited only by our imagination. As we continue to push the boundaries of what these materials can do, we open up new possibilities for their use in everyday life. As we delve deeper into the mysteries of materials science, we can expect to see even more astonishing breakthroughs in the years to come. The journey of discovery is just beginning, and the potential is truly limitless. Section 7. The body electric self-healing in biomedicine. The human body possesses an incredible ability to heal itself. Now, imagine harnessing this power in artificial materials designed to repair and regenerate human tissue. This is the exciting frontier of self-healing biomaterials. Scientists are developing self-healing hydrogels, biocompatible materials that can mimic the properties of human tissue. These materials have the potential to revolutionize regenerative medicine, enabling the creation of artificial organs and tissues. Imagine a future where damaged cartilage can be regrown, where wounds heal without scarring, and where organ transplantation becomes a relic of the past. Self-healing biomaterials are paving the way for such medical marvels. Section 8. Building the future. Self-healing in construction. The built environment is undergoing a transformation, thanks to the advent of self-healing materials. From self-healing concrete that can repair its own cracks to self-healing coatings that protect structures from corrosion, these materials are enhancing the durability and sustainability of our infrastructure. Imagine bridges that monitor their own structural integrity, repairing minor cracks before they become major problems. Self-healing sensors embedded in concrete can make this a reality, preventing catastrophic failures and extending the lifespan of our infrastructure. Self-healing materials are also being used to create more resilient buildings, able to withstand the test of time and the forces of nature. From self-healing roofs that prevent leaks to self-healing walls that resist cracks, these materials are making our buildings safer and more sustainable. The future of construction is self-healing, ushering in an era of durable, resilient, and environmentally friendly structures that stand the test of time. Section 9. The Self-Healing Revolution, a glimpse into tomorrow. The development of self-healing materials represents a paradigm shift in materials science. with far-reaching implications for our technological advancement and our planet's sustainability. We are witnessing the dawn of a new era, where materials are no longer passive but active participants in their own repair and regeneration. As we delve deeper into the mysteries of self-healing, we can expect to see even more astonishing breakthroughs, blurring the lines between nature and technology. Imagine a future where self-healing materials are ubiquitous, seamlessly integrated into every aspect of our lives. The self-healing revolution is here, and it holds the promise of a more sustainable, resilient, and technologically advanced future for all.